We're going to take a look at parallel and perpendicular lines and look to see how their equations are similar or different. So right here we have an example of parallel lines. So two parallel lines will never intersect. They'll never cross. They'll always be equidistant apart. And here we have two perpendicular lines. Now, perpendicular lines not only intersect, but they also intersect at a right angle. So that's really important. It's not just simply two lines that cross, but they cross in a very specific way at a right angle. Let's think about the properties of parallel lines. If we have a parallel line on the graph that has a specific slope, another parallel line, in order for it to be never touching, would have to have the exact same slope. So that is a property of parallel lines. Parallel lines have the exact same slope. If the slope of this line is, well, I don't know what it is, but if it's 1, then the slope of this one is also 1. If the slope of the line is 2, then the slope of the other line is also 2. They have to be the same. Perpendicular lines are a little bit different. So let's start with a positively sloped line that's sort of shallow. So if this has a positive slope, a perpendicular line would have to intersect at some place and cross it at a 90-degree angle. That line has to have a negative slope. So one thing that we do know about perpendicular lines is that they're going to have, they're going to be opposites. If one is positive, the other one is negative. So if we start with a negatively sloped line, right, something that slopes downward, the line that crosses it perpendicularly has to be positive. Now the only exception to this is that if you have a vertical line, then the horizontal line would be perpendicular. Neither one's positive, neither one's negative, but that's the only exception to the rule. But we notice something else with perpendicular lines too. If we have a very shallow positively sloped, the perpendicular line will be a very steep negative. And likewise, if we start with a little bit more steep positive line, then when we draw the perpendicular line, it's going to be a little bit less steep. The steeper we go with the first line, the less steep we go with the second line. So, as one slope is going up, the other slope is going down. So there's our two things. One's opposite, one's positive, or one's increasing while the other is decreasing. Well, the way this works out is that perpendicular slopes are opposites and reciprocals. So let's do a few examples of those. If the slope of one line is 1/2, well, the reciprocal of that is 2/1, and this, because this is positive, this would be negative. So 1/2 and -2 are opposite reciprocal slopes. We would know that if two lines had a slope of 1/2 and -2, they would be perpendicular lines. Another example, if the slope is -2/3, then the opposite reciprocal slope would have to be the reciprocal, 3/2, and because this one's negative, this one would be positive. Let's take a look at these two quick problems. Find the slope of a line parallel to y equals 2/3 x plus 4. So what we need to do is we need to find the slope of the old line. I'm just going to mark it sub O, just to say the old line, right? So here's the old line. The slope of that is 2/3. So the slope of the new line, the one that's parallel, would be the exact same slope, 2/3. That's it, we're done. For the second problem, though, what we need to do is we need to find the slope of a line perpendicular to this line. Okay, so the first thing we need to do is find the slope of the old line. Unfortunately, this is not in slope-intercept form. So we'll take this and solve for y, because we want y equals mx plus b. So we will subtract 2x from both sides. 3y is equal to negative 2x plus 10. We're going to put that x first just so we can keep the slope-intercept form. Then secondly, we need to get rid of that 3. Divide everything by 3. So y is equal to negative 2/3 x plus 10/3. What is our slope of the old line? Negative 2/3. Okay, so now because we want to find something perpendicular, the slope of the new line is going to be its opposite reciprocal. So this is negative, we're going to have a positive. We're going to flip it, positive 3/2. This slope would be the slope of the line that's perpendicular to this other one. So we're going to look at being able to write an equation of a line that's perpendicular to y equals 3x plus 10 that goes through 4, 8. So I'm going to sketch out what this might look like. We have an equation, y equals 3x plus 10. That equation has a y-intercept of 10, slope of 3. So there's that line. Now what we're thinking about doing is we're going to take another point, 4, 8, and we're going to, I don't know, 4, 8 might be somewhere around here. And we're going to look for the line that perpendicularly comes this line. So something that looks like that maybe. We're trying to find the equation of that green line. In order to do that, we do not need to do any graphing. We can just look at the equations. So there's the old equation, and what we should start with is finding the slope of that old line. So again, I'm just going to mark it m sub o to represent old, and that slope is 3. The next step is we need to find the slope of the new line. So because we're looking for something that's perpendicular, we're going to take the opposite reciprocal, so negative 1/3. So our new equation is going to have a slope of negative 1/3. Now, what we don't know is we don't know where that goes through the y-axis. From here, we need to find the y-intercept, which is just the same skill that we've been using. We have a point, 4, 8, that represents a y, and it represents an x. From here, we need to solve for b. So negative 4/3 plus b. We need to solve for b by adding 4/3 to both sides. 4/3 is simply 1 1/3. So b would equal 9 1/3. Okay, that's our y-intercept. That's where it's going to cross. And that makes sense. It should be somewhere in that area. We're going to go ahead and put our new slope in. Our new slope is negative 1/3. And our new y-intercept, 9 1/3. Okay, practice problem time. So you're going to pause and do these two problems. Good. Did you do it? Okay, good. Okay, so find the equation line parallel to y equals half x plus 2. Now the important thing here is the slope. So the slope, old line, is 1/2. Because we want to find parallel, the slope of the new line is going to be 1/2. So we have y equals a slope of 1/2 x plus some b that we need to find. Now, where does it go through? It goes through negative 8, 10. So let's go ahead and use that. 10 is equal to 1/2 of negative 8 plus b. We'll simplify to 10 is equal to 1/2 times negative 8, negative 4, plus b. Add 4 to both sides. And we get 14 is equal to b. So that is the y-intercept of the line that has a slope of 1/2 and goes through negative 8, 10. So y is equal to our slope, 1/2, and then our y-intercept, 14. Second problem, we're going to look for an equation of a line that's perpendicular to this line. Okay, it has to go through that point. So let's start with the slope of the old line, negative 2/3. The slope of the new line would be the reciprocal, 3/2, and because this is the old one is negative, the new one's going to be positive. So there's our slope. Okay, so we have y is equal to the slope of the new line, 3/2 x plus b. We need to find the y-intercept. We're going to use these points. 1 is equal to 3/2 times 9 plus b. 1 is equal to 27/2, which is 13.5. We'll subtract it. And b will be negative 12.5. Okay, so our equation is equal to y equals mx. We're going to use the slope of the new line. This is the perpendicular slope. And then we're going to use our new y-intercept, negative 12.5. Congrats!